So Professor Fabio Verdi from UFSCAR, who was the work package 5 leader, which took care of the actual implementation work.
Okay, good morning. So first of all, it's an honor for me to be here, and I'm very, very happy to present a snapshot of the outputs of NECOS project. I would like to thank a lot for the students, the undergraduate students, the postgraduate students, that they materialized the NECOS architecture as Professor Alex was presenting. So this is something very, very nice for me to make part of this team. So when Christian started this workshop, he asked, oh, wow, what we are doing here? Then I prepared this slide so to tell you that I'm here to show you maybe the first cloud network slice created by our platform between Brazil and Europe. This is my purpose here. I will show you a snapshot, a very short video that shows our platform working and running. As Professor Alex mentioned, we have 5 demos, each one exercising specific features of the NECOS platform. The one that I will show here is the first one, whose name is Must. What is this? This is the demo that created 2 slices between Brazil and Europe and exercised the multi-domain feature and mainly the elasticity. This is something that I will show here. So I need to choose one piece of work to show you here, and we choose the horizontal elasticity to show and present to you. If we have time, maybe I can present another one, another demo that is related to intelligent orchestration, that is very in line with what was presented by Nokia's ideas. What are the main goals of the Musts demo? As I said, is to create real cloud network slice, end-to-end cloud network slice between Brazil and Europe using local data centers, distributed data centers. So, and mainly in one of those slices, we created it to receive the Dojo platform that you here in CPQD knows very well. So the Dojo platform was our driver for creating one of our slices. Another slice created between Brazil and Europe is the touristic slice that I will not show you today. So what is elasticity? This is exactly what I will show you. And specifically, what is horizontal elasticity as being a key feature of any slicing solution, of any slicing platform. Elasticity is a key characteristic. So in NECOS, we have 2 types of elasticity: vertical elasticity and horizontal elasticity. Vertical elasticity is the capability of adding more resource inside a given slice part, a given slice provider. Horizontal elasticity is the capability of adding a new slice part, a new slice provider to the slice. So these are 2 different concepts. Obviously, adding a new slice part is more challenging than adding resource inside the same slice part. So when we decided to make this horizontal elasticity with the Dojo platform. It was very challenging for us because the Dojo is not only a service, it's a set of services. It is a platform, as I will show you in a very few minutes. So the demo, the setup is spread between Brazil and Europe. We have 2 slice parts for the Dojo slice. So we will deploy the Dojo platform in the edge and in the core. The core is a data center here at Unicamp, one of our partners here in Campinas, and another slice part is located in Madrid in 5 Tonic. So we have used those local infrastructures to be our slice providers for this slice. And finally, for the horizontal elasticity, that is what I just explained to you, we added, we need another slice part, another provider. So why we have horizontal elasticity? Because in a certain time, the edge part at 5 Tonic, so the service that is running inside this slice, the Dojo service that is running inside the slice part, needs more resources. But at edge part that is located in 5 Tonic, there is no more resources. So we need to add a new slice part, and then the UFSCAR comes into the play, and the whole process of adding this new slice part, configuring all the things that are necessary, orchestrate all the process, and then redeploy to scale up, in this case, the Dojo platform is done by our platform, following the workflows that Professor Alex just presented. All those components that were presented in the picture of the NECOS architecture were designed and implemented to support this subset of features. Totally automated, okay? So just a little bit of motivation. We can imagine that we have a IoT service that we need to track some goods in a ship or in a truck, and then the customers, the tenant that wants to receive the notification of those sensors about a given good is received across our slice, our Dojo slice, and the tenant can be aware of what is going on with his goods. For example, it's just a use case to exemplify the usage of this IoT or Dojo slice. So let me very shortly explain what is Dojo, because it's important to say that it's a set of components and services inside the Dojo architecture, including the services that are located at the edge, that in our case is in Madrid, and the core services of a Dojo are located here in Campinas. So what we have is, after the horizontal elasticity, we added another horizontal, another slice part, and what we have here at the edge are the IoT agents. So what is those IoT agents are components from the Dojo service to receive data from the sensors that are located at the edge. This is what Dojo does. And then these IoT agents receive this data from the sensor, temperature sensors, and then it's sent to the core to store, to make data analysis, and then send to the customer that is tracking his goods. This is the way Dojo works. So what we will do is to express the IoT agents that are running at the edge with a load generation, and then suddenly we need to create another slice part, and then those requests will be balanced between these now two edge slice parts. So of course, for this demonstration, we assume that the slice is already created. Okay, so we created the slice. So I will not show you the creation of slice, of course. So we have the test bed after the slice being created. So we have Unicamp slice part and 5-tonic slice part with the NECOS components in blue developed using Docker containers. Oh, and the IoT agents are there. The Dojo services are already deployed. This was done totally automatically by the NECOS platform. So this is the setup after the slice being created, and this is the setup after we do the horizontal elasticity with this new slice part now being part of the end-to-end slice. So now I will show the video. It's a 3-minute video. I think it's better for me to be here. Sometimes when we show the video, it's boring, but we try to abstract some boring parts like shells, like those. I'm not sure if this is the right one. Yeah, this is the right one. So what is going on here? We are showing the slice parts at the Unicamp. So the slice is already created. We log it into to see if all the components are there. So then we went to the 5-tonic to see if all the components are running, are up and running. And then we will start generating some load so that we can stress a Dojo component located at Madrid. So this is the idea of this video. Okay. So we are just showing here some IoT components, the master node, the workers node that are terminologies related to the Dojo platform. So we are just verifying that the things are okay. And now we will start the load generation. The load generation, we started doing some HTTP requests, simulated some sensors, and then we triggered the horizontal elasticity, but it's important to mention something here. Let me, I think, I can stop? Yeah. Please do it for me. I think one point is important to say, is about the trigger. The trigger. For this demonstration, our trigger is quite simple. We just monitor the CPU load of the machine that is hosting the IoT agent. So we define it like when the CPU load reaches 80% of usage, we trigger horizontal elasticity. In the other demonstration that I will show you if I have time, we have a smarter algorithm based on machine learning so that it can learn about the environment and then trigger the elasticity based on a smarter algorithm. This trigger is quite simple. So what we have here is the Grafana interface, the well-known Grafana interface, showing the CPU usage of the edge slice part located in Madrid, and when it will more or less reach 8%, and we will trigger the horizontal elasticity. And at the right side of the dashboard, we have the UFSCAR slice provider with nothing. There is nothing there, just to show you that the slice part at UFSCAR is not yet belonging to the end-to-end slice. Yes, please, Christian. So, what is going on here? As I explained, we will in a few seconds, I hope, to trigger. So the SRO detects the CPU load and triggers vertical and horizontal. Of course, we didn't do vertical elasticity here in this demonstration, just the horizontal elasticity, okay? Because it is what I want to show you. So at this time, the SRO, what is SRO? It's a component of NECOS, it's the heart of NECOS, responsible for monitoring the infrastructure and then triggers the elasticity, for example. And then what we are seeing here is that the slice part at UFSCAR, that is our new edge slice part, is being deployed, configured, and now we will start the monitoring of this sensors requests that are being balanced between these two edge parts now. So as you can see, now slice part, the new slice part at UFSCAR started having, receiving the monitoring metrics. This is totally automatic. This is done totally automatic by our platform. We just receive the policies from the tenant, and then we make all the components to work in an automatic way. I couldn't see what was there, but I think it's the IoT agent started receiving the requests, and now we can see the balance among or between these two edge parts, one in Madrid and another one in UFSCAR. And the core is, of course, is still at Unicamp. Okay, this concludes my demo for the musts. I think we can, I have like 1 minute. So what comes next is, this is a quite simple SRO, a quite simple resource, slice resource orchestrate, that is one component of the NECOS. The trigger is quite simple, but now we have another demo that exercises this intelligent orchestration. Okay, so this demo is well related to what was presented by NECOS and Nokia's presentation. We have these 3 control loops, which means that the first control loop that comes from the IMA. What is IMA? IMA is the subsystem of NECOS responsible for monitoring the end-to-end slice. So the second control loop is the SRO consuming these metrics from the IMA. This is the same process that we did for the first demo. What is different in this demo is the third control loop. The third control loop is inside the SRO, is totally based on machine learning algorithms. So the idea of this is to collect the KPIs of the service as well as from the slice infrastructure and make some analysis so that it can trigger elasticity based on those metrics so that they can keep the SLA of the service. So we have also a video, a very short video, that will show you the evolution of the machine learning data and the estimative being done by our SRO. So we can see in the top, can you stop a little bit, Christian? Just a little bit to explain. So we can see here some green dots and a yellow line. The yellow line is our SRO, our machine learning, embedded inside the SRO, estimating what will happen 30 seconds before the event. So we trained the algorithms in a local partner, and then when that yellow line reaches the threshold that we defined for this service, it will trigger elasticity, which means to add more resources. So please, Christian, can you, okay? So you can see that after making the elasticity, the KPI of the service, that is the line, the yellow line, stayed below our threshold. Okay, so this is a very short presentation of what we have produced so far. So we have other outputs, and feel free to talk offline or anything else. Thank you.
Thank you, Fabio.